this video, I'm going to show you how to solve systems of equations using the calculator and matrices. So first we're going to start with our word problem scenario. We're going to write the equations and then I'm going to show you how to set it up in the calculator. So we're given this scenario where Xavier, York, and Zenon are brothers. Xavier is the oldest and Zenon is the youngest. The sum of the ages of the three brothers is 121. Xavier's age is 22 less than twice Zenon's age. The difference between York and Zenon's age is 7. Write a system of equations to represent the ages of the brothers and then solve to find their ages. So the first thing we want to do when we're setting up our equations is to figure out what are our variables. What are our letters, our variables in math, going to represent in this problem? Well, what we're trying to find is the brothers' ages. So the three brothers we have are Xavier, York, and Zenon. Isn't that nice? X, Y, and Z. So we're going to use X to represent Xavier's age. We're going to use Y to represent York's age. And we're going to use Z to represent Zenon's age. All right, so let's write our equations. The first thing it tells us is the sum of their ages is 121. So if I add up all their ages, X plus Y plus Z, it's going to equal 121. That's the first equation. Next, it tells us that Xavier's age is, Xavier, anytime you see the word is, that just means equals. So Xavier's age is 22 less than twice Zenon's age. The than word means that we're going to do the second part of the sentence first. So first we want to do twice Zenon's age. If I do twice something, that means I'm going to multiply it by 2. So twice Zenon's age. Then I want to go back and do 22 less. Less, if you have 22 less dollars, then that would be minus 22. So Xavier's age is 22 less than twice Zenon's age. So that captures that sentence. The difference means subtract, between York and Zenon's age is means equals 7. So York minus Zenon, because the difference is 7. So now we've written our equations and we're ready to put them in the calculator. Before we put them in the calculator, we want to make sure that our X's, Y's, Z's, equal signs, and numbers are all lined up. We want them to be in matrix format. So the first one is perfect. It's all lined up. X plus Y plus Z equals 121. We want them to all fall in those rows. It has to be perfectly organized for us to put it in the calculator. If you notice this one, the Z is on the wrong side of the equal sign. So I want to minus the 2Z, so it's on this side. So I've got X. I'm going to minus the 2Z. And then I've got my numbers, which go on the other side of the equal sign, so it can stay there. So the only change that I made was I minus the 2Z to this side so that it would be on the left side of the equal sign and my X's and Z's would line up. Notice in this equation we do not have a Y. If that is the case, we always just put a 0 in as a placeholder for any missing variable that we have. All right, on the last one, notice we have no X. So I'm going to line up my Y. I'm going to line up my minus Z. And I've got a 7 there at the end. So my placeholder this time is I'm going to have a 0X to plug in. Also keep in mind that anytime you don't have a number in front of a variable, a 1 is always implied. So we know this is a 1x, we know this is a 1y, a 1z, a 1x, that's 0, negative 2, we've got 0, 1y, and this is a negative 1z. Now we're all set up, ready to put it into our matrices. You'll find the matrix button as the fourth button down. You'll hit second matrix. And we want to go over to edit and enter on matrix A. We're going to set up a 3 by 4 matrix because we have 3 rows, 1, 2, 3 rows, and 1, 2, 3, 4 columns of numbers. So that's why we're setting up a 3 by 4. Now I'm going to carefully type in each of these numbers. So I've got 1, 1, 1, 121 across the top. So 1, 1, 1, and I'm hitting enter in between each number, 121. Next row, 1, 0, negative 2. 1, 0, negative 2 equals negative 22. Next line says 0, 1, negative 1 equals 7. So now I've carefully entered in every single number here in my matrix. You can hit second, quit, or the mode button to get back to my regular screen. Now we're ready for it to do its calculation. We've entered in the data. We're ready for it to do this calculation. To do the calculation, you're going to go back to matrix, second matrix, and we want it to do some math. So we're going to scroll over to math, and we are looking for the option that says RREF. That's option B. So B is RREF. We're going to hit enter on that. And we wanted to do an RREF of matrix A because that's where we entered our data in. So I'm going to go to second matrix, and matrix A, that's where I put my data in. I'm going to hit enter there, and then I'm going to hit enter. All right, so this is my solution. Notice there is a diagonal 1. This is called the identity matrix. This means I found the solution. There should be a diagonal 1s and everything else should be zeros. The numbers at the side are your solution. So since it tells me in my solution 46, 41, and 34. Those are my answers, and they will give me the answers in the same order that I put them in. So notice when I put them in my calculator, I put my x's in first, then my y's, and then my z's. So the first one's going to be x, the second one's going to be y, and the last one's going to be z. So going back to my problem, this tells me that Xavier is 46 years old, York is 41, and Zenon is 34. We always want to make sure that we go back to the original problem and see if this makes sense. All right, Xavier is the oldest. That's true according to our numbers. Zenon is the youngest. Yes, he's only 34. The sum of the ages is 121. If we added them all up, they would be 121. Xavier's age is 22 less than twice Zenon's age, and we could do the math and figure that out. And the difference between York and Zenon's age is 7 years, which also checks out. So always go back to your original scenario and see if that actually makes sense. All right, example number 2. This time we have 3 families that went to an amusement park and they forgot to get a receipt for what they spent. The Gonzalez family knows that they spent $162 on their family. They have 2 adults, 3 children, and bought 5 meal tickets. The Jones family said they spent $151 for 1 adult, 4 children, and 5 meal tickets. And the Carey family said they spent $184.50 for 3 adults, 2 children, and 6 meal tickets. When they got home, they were wondering, how much did an adult ticket cost and a child ticket and a meal ticket? So they decided to use a system of equations to help them figure out this scenario. So we're going to write an equation for each family. But first, we always want to figure out what our variables are going to represent. Since I'm trying to figure out how much an adult ticket is, a child ticket, and a meal ticket, those are going to be my variables. So we're going to label adult ticket cost So this is going to be the cost of an adult ticket. C is going to represent the cost of a child ticket. And M is going to represent the cost of a meal ticket. All right, so now we're ready to write our equation. Notice the question you're trying to solve is usually what your variables are going to represent. So that's always a clue as to what your variables are going to be. All right, so first let's write an equation for the Gonzalez family. They spent a total of $162. They had 2 adults, 3 children tickets, and 5 meal tickets. The Jones family spent $151 for 1 adult, 4 children, and 5 meal tickets. The last one is the Carey family. They spent $184.50 for 3 adults, 2 children, and 6 meal tickets. So you can see this one is really nicely set up because all my A's, C's, M's, and constants are already lined up, ready to put in the calculator. So let's put it into our calculator now. All right, so again, we're going to go to second matrix. I'm going to go over to edit, and I again want a 3 by 4 matrix C. So I'm going to hit enter there. I'm going to go ahead and type in each of the coefficients. So the coefficient of A is 2, 3, 5, and 162. Next row, my coefficients are 1, 4, 5, and I'm just hitting enter each time to get to the next space. And 151, 3, 2, 6, and 184.5. All right, now I've entered in all of the numbers. I'm going to hit second quit to go back to my main screen. All right, so to be able to run the calculation now, I'm going to second matrix C again. I want to do the math on this matrix C, and I'm looking for option B. You can either scroll up or down to option B that says RREF. That's the option you're looking for. Hit enter when we want to do RREF on matrix CA. So go to second matrix, hit enter on matrix CA so that it says RREF of A. Then you're going to hit enter. Notice we have the diagonal ones. That tells us that we have found the solution. My solutions are over here to the side. So my solutions out to the side say 27.5, 16.5, and 11.5. So let's see what that means as far as our scenario here. That tells me, since my first variable was A, that tells me that an adult ticket is $27.50. C is the next variable that I entered in, so that tells me that a child ticket is $16.50. And a meal ticket is the last variable we entered in, which is $11.50. So the key to remembering what you're doing is look for option number B of RREF. Make sure you carefully put all of your coefficients in matrix CA and your constants at the very end. And this is obviously a much faster way of solving systems of equations than doing it by hand if you can use a calculator on the test.